Hello, good morning viewers. Still on bearing and distance. I think probably this is going to be our last tutorial on the bearings. Subsequently, we are moving on to the next topic, which is sort. So now let us read the question. The question says 3 points A, B and C are on the horizontal plane such that B is 25 meters on a bearing of 48 degrees from A, and C is on a bearing of 88 degrees and 138 degrees from A and B respectively. The question says we should find the distance of A to C, and secondly we should also find the bearing of A from C. So now let us form a sketch of this information. As always, we are going to construct the first bearing. The first bearing is 48, and we are going to construct it from A, which is 25 meters away from B. So suppose this is our point A. You know, every point has a north pole. So this is A. 48 degrees roughly will be something like this. This is 48 degrees. To B, so this is our B. It also has a north pole. Let me extend it. This is B. Okay, I'm not done. This is 25 meters. Okay, moving on. It says that C is on a bearing of 88 degrees and 138 degrees from A and B respectively. It means that C is somewhere here which we don't know, but it is on the bearing of 88 from A and 138 from B. So now let us start with that of B because it is a little bit closer. So 138 from B roughly, because you know east of B is going to be 90, but this is 138, it is greater than 90, so it will be roughly somehow like this. We are not going to assign our point yet. We are going to also construct that of 88. The line of intersection between this line and the other one will determine the position of C. We are constructing 88 from A. You know, as always, we are going to start from the north. And you can see from the north, we already have 48. We are moving to 88. Therefore, we have 40 extra left. So roughly, we have 40 here. So the point of intersection, this is where they intersect. So we can call this point C. And this is 40 degrees. We are done. The question says we should find the distance of A to C. We are looking for the distance from A down to C, which we don't know. Let me assign an X to that. This side is also not given, but let us fill some information here. This angle is alternate to this one, and alternate angles are equal. So this is 48 degrees because this is 48. Remember, this bearing is 138 degrees. An angle on a straight line is 180. It means that we have 42 left here to make it 180, the interior angle. But this is a single angle which we can combine together. 48 plus 42 is 90 degrees. Since this angle is 90 degrees, it means that the triangle is a right angle triangle, which we can apply Pythagorean's rule to find the value of x. But since the length is not given, we can go ahead and find it first. Let's call it y. This y is opposite to this angle 40 degrees. And this 40 degrees is adjacent to this length of 25 meters. So we can apply tan ratio, tan 40 degrees, which is the same thing as opposite y over the adjacent 25 5. Y will be equal to 25 if we cross multiply tan 40 degrees. So now let me use my calculator to find the value of y. 25 multiplied by tan 40, approximately, because we have 20.977, we can approximate it to the nearest whole number, and we say BC is 21 meters, approximately, to the nearest whole number. Having obtained this, we can now apply Pythagorean's rule to find the value of x. So A part. From Pythagorean's rule, you know this is the longest side, which is the hypotenuse. It is always opposite to our rectangle. So we call it AC squared will be equal to AB squared plus BC squared, according to Pythagoras. This is equal to AB. AB is given from the question as 25 meters, so we square this. BC is just what we have obtained as 21, so we have 21 squared. This is AC squared. If we take the square root of both sides, AC will remain alone here, and this is equal to the square root of 25 squared plus 21 squared. We are not going to apply plus or minus because all distances are positive values. Using my calculator, I'll press everything direct. 25 squared plus 21 squared, what I have is 1066. Then the square root of that is 32.64965, which I can approximate to the nearest whole number. This is equal to 33 meters to the nearest whole number. So the value or the distance of A from C is 33 meters. We are done with A part. Now let us move on to the B part. The B part says we should find the bearing of A from C. What it means from is to calculate the total angle from C. This is C, so we are going to calculate the total angle from the north of C down to the line leading to A. That is the bearing of A from C. But let us fill some information here. You know, we can extend this line. By extending this line, we have a straight line, and you know, angle at the back on a straight line is 180 degrees. Now if we are able to obtain this angle here and combine it with 180, we shall obtain what we are looking for, the bearing of A from C. But look at this interior angle, it must be 50 degrees. Why? Angles, the sum of all the angles on a triangle is 180. We have 90, we have 40. What is left is 50 for it to be 180. This angle also is alternate to this one, so they are exactly the same. So we have 42 here degrees. This is also a straight line by the side. The total angle there is 180. We have another 180. Total is 360. So to find this angle, we can subtract this and this from 180. 180 minus 50 is 130. If you subtract 42 from there, you shall obtain 88 degrees. So now we are free to add 88 and 180 for us to get the bearing of A from C. Let us do that. So the B part, we say that the bearing of A from C is equal to 180 degrees plus this 88 degrees. And by adding these 2 degrees together, we're going to obtain 268 degrees. So 268 degrees is the total angle from C down to the line leading to A, which is the required angle. So this is all I have for you today. Thank you for watching. Don't forget to subscribe to my YouTube channel for more exciting videos, and don't also forget to share it to your learning colleagues. Bye bye.